All right, let's look at the series. All right, so series is going to be the sum of the bunch of terms, right? In this case, infinitely many terms. For example, if you have a summation, n goes from 1 to infinity, so n is the index. It starts from 1 and then go 2, 3, 4, and so on. All right, then so what we have is first term is going to be, of course, n starts from 1, so a1. And then you have add a2 to it. Then we add a3 and so on. So this process keep on going forever. So you have infinitely many terms. And we want to find the sum of all those terms, right? The way we look at it is this, using something called the partial sum. Partial sum is simply the first n terms added together. So sum of the first n terms. So Sn is going to be so a1 plus a2 plus, and then you don't go forever. We actually stop at an, right? Then we can just define it. So the infinite sum is going to be the limit of the partial sum as n approaches infinity. So we know that this is going to be a limit of Sn as n approaches infinity, right? So since this is a limit, it might not converge to a finite number. It might diverge, right? Or limit might not exist, right? So let's look at a couple of examples, right? So if you have a summation, n goes from 1 to infinity, and each term is always 1. So it's going to be, so this is basically 1 plus 1 plus 1 plus and so on. So you have infinitely many ones added together, right? And this is almost like a common sense. So we know that if you keep on adding 1 all the time, it's gonna get larger and larger and larger. So we actually know the answer. So we know that the answer is going to be infinity, which we call divergent. Right? All right, but let's use the partial sum. So what would be the partial sum for this particular series? All right, so it's going to be, so you have to add the first n terms. So you have a 1 plus 1 plus all the way to 1. And we know that there are only n terms or n ones, right? So if you add n ones together, and we know that this is going to be equal to n, right? All right, so if you want to evaluate this, what we need to do is we need to take the limit of partial sum, in this case n, as n approaches infinity, right? And obviously this limit goes to infinity. So it makes sense that we have this answer right there. So I'm going to check this. All right, so this is not that interesting, but if you keep on adding 1 every time, of course, it's going to blow up to infinity, right? How about the next example, right? So this is a summation. N goes from 1 to infinity, and 1/2 to the nth power. All right, so this is going to be, this is going to be equal to, all right, so first term will be 1/2, yeah. All right, then the second term is going to be 1/2 squared. And third term is going to be 1/2 cubed. And so on, so you say dot, dot, dot. All right, so let's find the partial sum. So Sn is going to be equal to, right, so we have 1/2, so this is the first one, and the second one would be 1/2 squared. And then you keep on doing that until we get 1/2 to the n. So that's the first n terms. All right, then to find the sum, the trick is we're going to multiply by 1/2. So you have a 1/2 Sn is equal to, all right, so 1/2 times 1/2 gives you the next term, 1/2 squared. So 1/2 squared times 1/2 is 1/2 cubed, and so on. Keep on doing that, then you're going to get 1/2 to the n, and the last term is going to be 1/2 to the n plus 1. Right? Then what we do is we can just simply do subtraction. Right? Then we'll see that Sn minus 1/2 Sn is going to be 1/2 Sn. This is equal to, right, 1/2 minus 0 is 1/2. And you see that, 1/2 square minus 1/2 square, so they cancel out. So we can cancel those out. Right? And you can see that all these guys will be canceled out too, up to 1/2 to the nth power. Right? So last one is 0 minus 1/2 to the n plus 1. So you have, let's see, minus 1/2 to the n plus 1. All right? Then what we can do is we need to get rid of 1/2. So I'm going to multiply by 2. So partial sum Sn is equal to, right, so multiply by 2, we get 1. And multiply by 2, you get, so one of the 2 cancel out, so it's going to be negative 1/2 to the nth power. All right. Then what we can do is we can just take the limit. So if you take the limit of the partial sum, which came out to be 1 minus 1/2 to the n as n approaches infinity. Right? So you can see that here, as n approaches infinity, 1/2 to the large power is going to be very, very close to 0. So this guy approaches 0. So therefore, you end up getting 1. Right? So this is going to turn out to be 1. Right? Right. So is this reasonable? There's a geometric way of making sense out of this summation here. Right? Think about just a number line and see how this summation adds up. All right. So here, let's say you start from 0, right? And the first step is you're adding 1/2. So it's let's say 0 and a 1, right? So 1/2 is going to be right here, right? So first step would be just adding 1/2. So this is going to be our A1. So A1. All right. Then from there, we're going to add 1/2 of the remaining amount. So it's going to add 1/4. So you can see that it's going to go here. All right. So this is going to be 1/2 plus 1/4 is 3/4, like that. All right, then this is going to be A2 is added. All right. And the next step would be, so there's 1/4 left, then you're going to add a 1/8, which is 1/2 of the remaining. So it's going to take a 1/2 of the remaining step toward 1. So this is going to be 7/8. And then it's going to take a step like that. So it's A3, right? Then you know what's happening, right? So next step would be it's a halfway toward 1, and a halfway toward 1, and halfway toward 1, and halfway, right? So keep on doing that. So you can see that the sum is approaching 1, right? Or, closer and closer to 1. So therefore, we have this sum equal to 1. All right? That's it. I hope that this was clear.